Okay, I'm going to be teaching about tree diagrams, but first I want to go back and review what we did yesterday. Those are called contingency tables, and I'm going to find out right now about your sporting habits as well as your desire for chocolate milk. Choco milk and not, no wait, let's go with not chocolate. Let's go with chocolate. Like if you're going to have a shake, would you rather have a chocolate shake or a vanilla shake? And then, are you a one sport person? And by this I mean, like, of course you can play more than one sport. I mean, everybody can play soccer. You kick the ball around, you try to get it in the goal. But I mean, like, you're actually enrolled in play on a team. Okay? Are you a one sport person or more than one? I'll say, how about if I say greater than one? Greater than one sport. Like on a team. Okay? So, you got to be one of these things, unless you go with no sports. Totally. Right? So then I guess we have to have a no sport option. Because maybe your sport is like, or, yes, underwater basket weave or whatever. So we're going to say no organized sports. And that's not a bad thing. I mean, some people are like amazing piano players, and they spend 3 hours a day on piano, and they're going to do that for the rest of their life, and they don't need to be in sports or whatever. Yes. I am saying that theater and music do not count as a sport. I think most people would not say that that's a sport. It's an activity, clearly, but I don't think that if you're in theater that you can say you're in a sport. And so, it's no sport, it's one sport, more than one sport, or no sports, and therefore I'm going to assume no sports means you do something, which is hopefully things like theater and whatever. Okay, so how many of you are in the, you'd order a chocolate and you are a one sport person? Ooh, that's a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. Who would go with vanilla and you're in a sport? 1, 2, 3, 4. Okay, keep your opinions to yourself. How about you're in more than one sport and you like chocolate? 1, 2, 3, 4, 5, 6, 7, 8. All right. How about you're in more than one sport and you would pick vanilla? 1, 2. Just keep your hand up high. I can't tell. I want to check that again. I guess there's only one. Oh, he's high-fiving somebody. Okay, so it's 1. And then, no organized sports, but you would choose chocolate. Interesting. 0. Okay. And no organized sports, and you would choose vanilla. All right. Excellent. Now we've got everybody represented. We should, because I think everybody would have had to raise their hand at some point, unless you're like, I would not choose either chocolate or vanilla, which I didn't even make a category for that. So, all right. We add these together, and we have a total of 26. We add these together, we have a total of 6. And then we add them across this way, and we have 22, and we add them across this way, we have 9. 9 and 20, oh, and then across this way, 20. And I add them all up, 21 and 32, and then hopefully that adds up to, yes it does, perfect, my chart worked. So now, we do probabilities based on it. If I were to toss a die out there, how about a dime? Toss a dime out there. Don't touch. Just let it. All right. Now, what's the probability that that die, that point, sorry, in this case, landed under a person who would choose vanilla? Write down your answer in the remarks app as a fraction, and then hold it up to me so I can see it. Yes, I'll ask the question again. What's the probability that that randomly tossed coin would land under someone who would choose vanilla? It's a fraction. It's just a fraction. do not need to simplify it. You can just leave it as a nice, the numbers that were on the screen. All right, I'm seeing almost unanimous opinion on this one. All right, not completely unanimous. All right, here's what the two most common answers were: 5 over 32 or 6 over 32. I think the 5 was factoring in, you've got a 4 plus a 1, and was there a reason to leave out somebody that, based on no organized sports? I don't think I said anything like they had to be in a sport. So if I just said something about vanilla, then it should be the 6. So it's 6 out of 32. All right, next one. Given that I know it landed underneath the person who likes chocolate, what's the probability that they would be in one sport? Given that I know it landed underneath the person who likes chocolate, what's the probability then that they would be in one sport? Okay. Thank you. And you are correct. Good, 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 good. Everybody's got it right. 18 out of 26. Nice job. As soon as I said given they like chocolate, you should have been able to say, oh, I know I'm in this row right here. They can't pick the numbers from anywhere else. All right. Next one. Is there any correlations that seem to go together? Is there anything we can draw from this step? Like, does it seem like people that are in more sports like chocolate, or is chocolate more popular than vanilla? At least we could say that, right? Okay. Because the total for chocolate was 26, total for vanilla was 6. How about can we make any conclusions about one sport or more than one sport? If you're in one sport, you're more likely to like chocolate than vanilla. That's like an 8-to-1 ratio versus if I reduce that, that would be a 9-to-2 ratio. So you could say you're almost twice as likely to like vanilla if you're only in one sport. Because this ratio is 8-to-1 versus this ratio is like 9-to-2, which is basically you're more likely to like or vanilla if you're only in one sport. Or if you're in multiple sports, you're more than twice as likely to like chocolate. That's also interesting. Did you know that they tell the cross-country skiers to burn a tremendous amount of calories? They like seriously burn an insane amount of calories in the cross-country skiing. And I've done it before, so I know what they're talking about, because it's not only working your legs, it's working your arms at the same time. Like normally running, you're just working your arms, right? Legs. But when you're cross-country skiing, you're working your arms really hard too, because there's a ton of pulling that goes into it. So you're doing your whole upper body. It's not just like your biceps. It's your biceps, your triceps, your back gets into it because you're pushing on the poles. Because if you're really good at it, you're working your upper body really hard and your lower body really hard at the same time. So they burn a ton of calories. You know what their suggested drink is? Chocolate milk. Yep. After your workout, it's supposed to be. So there may be a correlation there. Maybe. I don't know. Okay. All right. That was a contingency table. I just wanted to talk you through one of those. Let's talk about tree diagrams then. So tree diagrams kind of look like this. And they're kind of handy because they work for many, many, many different types of situations. Because they're very, very flexible. It's not like a coin where it can only have two choices, heads or tails. A tree diagram, you can make the first option have 3 choices. Like, let's say that this summer, your family was planning a trip. And for this summer, you're either going to go to Alaska, or you're going to go to Utah, or, okay, you're going to go to Hawaii. All right. So if you're going to go to one of those 3 places, let's say that your dad really wants to go to Hawaii, so there's like a 75% chance you're going to go to Hawaii. And there's like a 20% chance you're going to go to Arkansas. You could figure out the chance in Utah, right? This was Alaska. The Utah one is not likely. What is? Oh, what did I say? Arkansas? Sorry, Alaska. Isn't it AK for Alaska? Like, okay. All right. So anyway, this is Alaska. This is Utah. What's this got to be? Point what? 0.05. Because these, you get that naturally that they have to add up to 100%. Okay? All right. So it was kind of a given that we're going to go on a trip, just to clarify that. I suppose it's possible you wouldn't go on a trip, and we could add in a chance for that. If you're going to go on a trip, these are the 3 places. Then you can make a little side chart like this. Like if we go to Alaska, it's pretty likely that we'll see. Do you know what the big site is everybody wants to see in Alaska? The mountain. What's the mountain? What's the mountain called? Denali? I think it's McKinley. Oh, Denali is the park. You're right. So there we go. So McKinley. So we're going to say Mount McKinley. I don't even know. Okay, Mount McKinley. All right. And this is not going to go to Mount McKinley. So let's say that there's an 80% chance that you'd go to Mount McKinley and a 20% not. And within Utah, is there anything big in Utah that people like to see? Skiing is a big one. Yep. But if you're going in the summertime, probably not much skiing. Well, there's only a 5% chance you're going to go to Utah anyway. So, all right, let's go for on the Utah one. Let's go with since it's not skiing time. I actually visited there in the summertime. You're really close to the Grand Canyon when you go there. The Grand Canyon is technically in Arizona, but it's really close to Utah. Like it's just over the border. So a lot of people do go to the Grand Canyon. So let's go with GC for Grand Canyon, and this is not. By the way, I do recommend it if you're ever down in Las Vegas. A lot of people have been to Las Vegas. How many of you guys have been to Las Vegas? All right. You were only 2 hours from the Grand Canyon when you were in Las Vegas. So if you ever go to Las Vegas, just take a 2-hour car ride out to see it. It is amazing. Just because all you need to do, I went out there for like an hour and a half, and I got the feeling for it. I mean, I'm sure it's even cooler if you stay for a week, but I got to walk out there, just like be amazed by how big and deep and scary kind of because you're up so high, and it was amazing. So anyway, so let's say that there's only a 20% chance you're going to go see the Grand Canyon, 80% not, just because in this case you don't think you're likely to go there because it's actually a car ride out of Utah. So do you get how flexible these are? They don't have to be the same numbers. They can be all different numbers. In Hawaii, what's the thing you'd really think would be cool to do in Hawaii? All right, so you do the helicopter over the volcano. Heli-volc. And heli skiing is different. Anyway, heli-volc and then not heli-volcing. And let's say that there's a 70-30 chance of that. No, it could be heli-volc 70% and then 30% chance. If you don't go heli-volcing, then maybe you're going to go deep sea fishing or whatever. So it doesn't have to be not. Like this one wasn't Alaska or not. It was Alaska or Utah or Hawaii. So not's an option, but it's not required. All right, so now that I've taken the time to make this chart, I now can get all these different probabilities. I'd like you to grab your calculator and figure out with me what's the probability that you'll end up in Utah seeing the Grand Canyon. Do you have a calculator? You borrow one of mine. Probability of Utah seeing the Grand Canyon. Well, what should you do? Is it just a 20% chance? No. You got to factor in also that there's only a 5% chance you're going to Utah. What do you do with probabilities? Do you think that the probability should increase? Like add them together? That doesn't make any sense. What do you think you should do? Multiply. Yes, that's a good shot. You multiply them. So you multiply. Remember when I had the die and the other die, and I had 6 choices here and 6 choices there, and I multiplied them? I got a total of 12. There's a lot of multiplying happening in probability. All right. So did you take 0.05 and 0.20, and that multiplies to 0.01? So there's only a 1% chance you'll end up seeing the Grand Canyon this summer. Get what I'm saying? All right. Now, what's the probability you're going to be seeing a volcano from a helicopter? Other side, the buttons here. Yeah, you can Yes. And how did you do that? 52.5 to what? 525. Raise your hand if you could agree with that answer. Okay, good. So what do you think happens when I add all of these probabilities up? They add up to 100%. Because one of those things would have to happen. All right. Now, here's how it can get harder. Actually, let's do two more. Let's figure out the Utah and not seeing the Grand Canyon. What's the probability of that one? Utah, but not seeing the Grand Canyon. What is it? 0.04? Do you get that you're 4 times more likely to not see the Grand Canyon than to see the Grand Canyon? And that makes sense also because it was an 80-20 split. That's 4 times as big. Okay, how about this? Given that all of a sudden the plans change and you are going to go to Utah. Yep, it's Utah for sure. Now, what's your probability of seeing the Grand Canyon? 20%. Do you get how you can just skip this route completely and just go to this? But I want to show you another way that because it's always good to see like why this works. Remember how I said probabilities are always what you want over what's possible? If that's the thing that we want, some kid really wants to see the Grand Canyon, okay, so there's only 1% chance of it happening. Technically, you're doing 0.01 divided by all the things that could happen. All the things that could happen added up to 100%, or 1. See how I'm 0.01 divided by 1? I don't need to divide by 1, though, really. It doesn't do anything. But when I change the problem to say, given that we're going to go to Utah, then do you get that what's possible now is the 0.01 plus the 0.04? Those are the only two things that are possible. Okay, I want you to shut your iPads right now. So I'm going to get too deep into your iPads and you're not listening to what I'm saying. All right. Do you get that if I say we're going to Utah, that these are the only two things that are possible then? 0.01 and the 0.04. So if I want to get that answer, I can say what I want over what was possible. Those two are the two things that are possible. If you divide 0.01 divided by 0.01 plus 0.04, which is 0.05, you'll end up with the right answer. All right. Now, if I asked you to change this question then totally to if you know you're going to end up going to Alaska, what's the probability that you will not see Mount McKinley? It's an easy answer. 20%. All right, now if I had both of these numbers, 0.16 and 0.04, how could you have gotten that answer of 20% using the 0.04? I'll say it again. The question is, if I'm going to go to Alaska for sure, then what's the probability that I'm not going to see Mount McKinley? How would I use the 0.04? Yes. Yes. That's what you want, right? Yep. 1/6, right? And then this adds up to 0.20. And when I actually divide 0.04 divided by 0.20, you're going to get the right answer, 20%. All right. So I'm just trying to show you that this always comes down to what you want over what is possible. These are the two things that are possible. All right. I want you to make a chart now. We're going to do this based on your iPad, make a little tree. I want you to make this tree situation. Now, you don't know how many choices I have, so don't start yet. All right. Let's say, Mr. J, what's something that you sometimes come home and this happens? I don't know, you have to let the dog out, or you find that your sister is up on top of the piano, standing up there again, or whatever. What happens sometimes? Fairly common. No, we don't want awesome. It's like only a 1 in 1,000 chance. Okay, good. What would you say is the probability of the dog be sleeping when you get 95% chance the dog is sleeping. All right. So we're gonna make split two choices. Either the dog is sleeping or dog not. And what would you always say the chances are again? 95% dog sleeping. Okay. And now, what's another thing that might happen when you get home? Do you eat when you get home? What is the probability you're going to be eating within a half an hour of getting home? Okay, 75% chance you're going to be eating something. Now, if you are eating something, give me two different things you might choose from. Okay. Seriously? All right. Meat, the number one snack choice of Minnesotans. It's true. The number one choice if you have unlimited options. More people would choose meat than any other kind of snack in Minnesota. Yes, yes, torture. Okay, so what's your probability of eating the pepperoni? 65% probability of getting pepperoni, and then we'll go with the other is the apple. So let that leave us the apple. 35? 35 apple. Now, here's my question. Today, when Mr. J goes home, what's the probability that his dog will be sleeping while he is eating a piece of pepperoni? With 75% eat and 25 not? Okay. And then the pepperoni was 65, 35. And not, there's really nothing to choose from, right? Because if you're not eating, then we don't have a choice there. It was. Nope. When he gets home, we're checking on the dog first. Is the dog sleeping or not? That was the first thing I asked him, and so that's the first thing I looked at. Then, the reason I only filled out that part of the chart is just because I said, when I asked you the question, what's the probability the dog will be sleeping, he'll be eating a piece of pepperoni. So you basically have to just multiply those three things together. What did you get? 46% chance? All right. And of course, now that we've told you that, it probably changes everything. Is it the Heisenberg principle? That basically, as soon as the person that you are observing knows they're being observed, they act differently. So now, you're probably, when you go home today, your dog won't be affected by this. The dog is still having a 95% chance of sleep. But your eating will be affected by the fact that you talked about it. You'll be like, oh, this is weird now. Oh, I'm actually deciding whether I should have an apple or pepperoni. All right, so now I'm going to change the question to, I'm going to just give you some probabilities, and I want you to figure out what would your chance of this happening. You're going to be walking home. Eventually, at some point, you're going to be walking, unless you ride the entire way all the way to your house. So you're walking, and a dog will bite you on the way home. What's the probability of this? The probability is probably only 1 in 1,000, but it happens. Dogs bite. So let's say that you have a 1 in 1,000 chance of being bit by a dog on the way home. And then most kids at some point in their life break a bone. How many of you have broken a bone already? All right. How many of you have broken more than one bone? All right. So on average, you guys have broken at least one bone. So, but that's over many, many days of your life. So I'd say there's also a 1 in 1,000 chance that you're going to break a bone today. Okay. And then also, let's throw in, how many of you drink milk on a regular basis? All right. What do you think your probabilities are of drinking a glass of milk on a typical day? And for many of you, it's 170, 90, 80. Okay, averaging what I heard from you guys, we're going to go with 80% chance that you're going to be drinking a glass of milk. All right, so then I want to know what's the probability you're going to, today, drink a glass of milk, break a bone, and be bitten by a dog. With you, it is a higher chance because you break bones all the time. Every time she says something about breaking a bone. Yes, the probability on the dog was 1 in 1,000. The probability on the bone, we also said was 1 in 1,000. We're doing all of them. So it, yep. And the last one was the milk probability. I went with 80% chance on the milk. Yes. One more factor, the fiscal cliff. Did you guys hear the whole fiscal cliff deal? Did you know that affected milk price? They say that since they haven't actually fixed the farm part of the milk deal, there's some kind of a farm program that causes milk prices to be lower than they normally would be. Well, that program is run out, so it'll be interesting to see what happens. They say milk price could like triple from what it normally is. So normally milk is like $3.50 a gallon or so, and they're saying that it could be, well, triple's probably strong. I did hear numbers of $8 or $9 a gallon for milk, which would be kind of expensive. For some of you guys, how many of you guys have like 4 gallons of milk in your fridge, like at all times? Okay, so just think about that. That could be 8 times 4. That's $32 worth of milk all the time in your fridge, and so it's draining. So that could add up to lots of money. All right. If there's only a 1 in 1,000 times a 1 in 1,000 times what's the other one? 80%. I could say 80 over 100, or I could say 0.00 tenths, hundredths, thousands, 0.001 and 0.8. When I multiply them all together, I obviously have an 8 in my answer. Yes. I already have taken 10. All right. And then I'm going to multiply this all out. 8, that's an 8. And then I move the decimal over. 1, 2, 3, 1, 2, 3. There's 6, 7 spots. So that's 0.1, 2, 3, 5, 6, and 8. That makes it move over 7 spots. Obviously, it's not likely you're going to break a bone and be bit by a dog and drink a glass of milk. Could you have it happen to you? Yes, it's extremely rare. Is it more likely to happen to you now that we've talked about it? That's an interesting. The dog is probably not affected, unless all of a sudden, could you make it happen? Of course you could make it happen. It'd be very easy to make it happen. Annoy a dog by pouring the leftover of your milk glass on top of his head, and then, well, maybe he wouldn't bite you because of that. They're not that way. Taunt the dog. They don't like taunting. With a piece of pepperoni. You could reference that thing before. And then, yes, right when he jumps up to bite it, you stick your finger in there, and all of a sudden, boom, got bit by a dog. All right. So this is based on assuming randomness. And if you change the randomness part, it won't work anymore. All right. Next, I want to just do a last little example of the kind we did before, where you have two things, a coin and a die. So if you got a coin and you got a die, and you got heads or tails as possible on the coin. Now, there's a dime on the floor. There it is. Thank you. There's 2 choices on the coin, heads or tails. There's 6 choices on the die, 1 through 6. I want you to take a guess what's going to come up. Like, let's say you think it's going to be heads and 2. Or whatever. Think of your own thing. And I'm going to roll this out, and I want you to tell me the probability. First of all, figure out what you think is going to come up. And then tell me what the probability of that is. Yep, same thing. They're both going to come out on the table, and I want to know your prediction of what's going to happen. Of this heads or tails, and of this one number. And it's 1 through 6. Yes. Don't tell me your prediction. Don't tell me your prediction. No, just write it on your paper so that you can prove that, because there'll always be somebody who says, yeah, that's what I thought. But I want to actually have it written on an iPad so you can prove that's what you thought. Ready? Got your prediction? Predict once. One die. One die, one coin. All right. All right, so how many choices are there? 2 on this, 6 on this, times it. 12 things could happen. What's the chances you'll be right? 1 in 12. If there were 12 of you in here, how many people would probably be right? 1. If there's 24 of you, which is closer, then how many should be right? About 2. Let's find out how many are actually right. It is tails and 5. Anybody have it right? One person had it right. All right. Good job. So now, that's a little lower than what I would expect, right? Now let's see. We'll try it again. Everybody take another guess. Write it on your paper, too. Like what you think it's going to be. Ready? Got it? Got your second guess? All right. There we go. Tails and 6. Oh, yeah! There's 2 people got it. All right, good job. So, now that's more average. That's kind of what I would expect to get. Last hour, I had 7 people get it right. And just on one roll. But then, they didn't get it right on another one at all. Like, nobody got it on another one. And that kind of averages out a little bit more. Yes? So between 2 and 3, I would agree with you. 2 and 3 people should be getting it right. And we got 2 the one time, and 1 the other time. So you guys are actually getting a little unlucky, so I bet right now you might get lucky. Do I really think there's an increased probability right this second? No. But over time, if I do this enough times, the law of averages, if I do it enough times, will be that you should average about 2.66, like you said, people per class. All right. You got another guess? All right, here it is. Heads and 6. Now, why aren't you guys picking 6? You got it right? Okay, so one person had it right. All right. You know why? How many of you picked 6 that time? Only one person. How many picked 1 that time? Nobody. Remember what I said yesterday about how people like the middle? See how nobody's picking 1 and 6? Because people like the middle. They like to be at 2, 3, or 4, maybe 5. It's a little high. All right. Make one more guess. If I played the game 12 times, wouldn't you be likely to win one? We're not gonna, but okay. Heads and 2. Did you win twice? This is your first time winning. Okay, good job. All right. All right. One more time. Just take one more guess. One more guess. Just feeling it. Oh, yeah, there's always that. You got your numbers, and you don't want to give them up. People do that on lottery all the time. And I get how they get stuck, because then, what if they've played it like 5 times with these certain numbers? And then what if they stop playing it? And then it comes up. And then they'll be like, oh, those were the numbers. I should have just played it one more time. It's so painful. So then they kind of get stuck playing the lottery forever, because if they ever quit, they know that that'll be the time that their numbers come up. So I encourage you to never pick some numbers like that, and then because you'll be forced to play the lottery forever, which is like the worst curse, because they'll never win. Somebody has to win, but more chance of getting hit by lightning. Okay, here we go. Tails and 6. All right, some of you went outside the box. You forced yourself to go on those high numbers, or the outsides, not the middle numbers. All right, anyway, that's a good example of probability, having 2 numbers, 2 things, and you multiply them together to see how many total things. That's all of the options, like heads 1, heads 2, heads 3, heads 4, heads 5, tails 6, tails 9. Or no, there's no 9. Anyway, those were all called the sample space. But remember that. Sample space is what all of the different options are. And what you wanted was like a heads 6, or whatever you guessed, out of how many options there were, and there's only one of those out of 12 options. Because what you want over what's possible. All right, that sums up what you need to know for today's. We'll do the first problem together off the worksheet. So everybody find the worksheet. It's under Schoology. And, is Schoology down right now? All right. Go for it. Here, take this with you. That's your passing home. Okay, here is the answer key for the homework for today, just so you get an idea what the problem should like. Basically, you have to make a tree. I do not require you to label your tree with all of the little pieces because it's just really hard to draw that small to make it work. But you got 3 choices of entree, 3 entree choices, 2 vegetable choices, so you got a little branch that has 2 choices. 2 choices. And then each of those has 2 choices at the end, so your tree kind of ends up looking like that. Then they're going to ask you questions like how to multiply out these, and you just have to multiply here and here to get here. Those are pretty easy. Let's move on. Then there's this kind, and this is like a little puzzle. What you're trying to do is figure out, well, if this is 0.6 and this is 0.42, can you tell what that would have to be? Because 0.6 times what would make 0.42? Do you get what I'm saying? And you could figure out that has to be 0.7 because 0.6 times 0.7 would give you 0.42. So all of a sudden now you know that A is 0.7. All right, so that one's like a little puzzle. Then there's going to be some problems like this where you actually have to multiply these out. You did find one little mistake on the worksheet. I think this says out of 21, and then here it says out of 20. Don't worry about it, just leave it out of 20. And you know, I get that this number should be a 21 or a 21 of the other, and it's both. But just leave the numbers the way they are and use them to multiply them. Okay, that's all I got for you. If the worksheet doesn't open today, later on it'll open. Did any of you get it open? Oh, through the app apparently it's working. So if you haven't already